Now for the electric field. Electric field. Example. In the Bohr model, taking the radius of the hydrogen atom as R is equal to 5.39 times 10 to the negative 11 meter. Find the strength of the force on the electron. Its centripetal acceleration and its orbital speed. Okay. Using the formula from the Coulomb's law, we have F is equal to Q1, Q2 over 4 pi EO, permittivity of free space, R squared. Okay, substitute the values. We have 1 over pi OE. This one is also equal to 1 over 4 pi EO times Q1, Q2 over R squared. This one is equal to 8.99 times 10 to the 9. That is also 9 times 10 to the 9. Let us use the true value, which is 8.99. 8.99 times 10 to the 9 Newton meter squared. F is equal to 8.99 times 10 to the 9 Newton meter squared or per Coulomb squared times the value of the electron is 1.60. We're going to use 3 significant figure times 10 to the negative 19 Coulomb squared over R is 5.39 times 10 to the negative 11 meter squared. Okay, for the force, that is equal to 7.92 times 10 to the negative 8 newtons, or that is also equal to 79.2 nanonewtons times 10 to the negative 9. Okay, this one is the F. Now for the acceleration, we have force over the mass. Force is equal to 7.92 times 10 to the negative 8 newtons. 7.92. 7.92 times 10 to the negative 8 newtons divided by the mass of electron is 9.11 times 10 to the negative 31 kilogram. Okay, the acceleration now is equal to 8.69 times 10 to the 22 meter per second squared. Newton is kilogram meter per second squared. Remember that Newton is kilogram meter per second squared. Therefore, we can cancel your kilogram. Then the unit would be meter per second squared. Now, for the orbital speed, we have acceleration. Centripetal acceleration is equal to v squared over r, where v now is equal to square root of ar. Acceleration times the distance. Therefore, acceleration square root of 8.69 times 10 to the 22 times r, which is 5.39. 5.39 times 10 to the negative 11. 5.39 times 10 to the negative 11. 5.39 negative 11. Okay, therefore, V now is equal to 2.16 times 10 to the times 10 to the 6 meter per second. Example, find the electric field at a distance of 0.3 meter from a charge of 3 nanocoulomb. Okay, remember that the formula E is equal to KQ over R squared, where K now is 9 times 10 to the 9 Newton meter squared per coulomb squared times the charge of 3 times 10 to the negative 9 over R, which is 0.3 meter squared. 9 coulomb. Okay, therefore this one is equal now to electric field 3 is equal to 300 newtons per coulomb. Find the electric field. And point P in figure below. Joule. To the charge shown. Okay, this one is the given figure. We have positive charge, negative charge, positive charge. Okay, the requirement, find the electric field point P in figure below due to the charges shown. We have from point P to negative charge, that is 45 centimeter. From point P to positive charge, 45 centimeter going to the right. And from point P going to the left for the positive charge, we have 45 centimeters. Okay, and then the given charge here We have for the negative, we have negative 8 microcoulomb. And this one is positive 12 microcoulomb. And this one is positive 2 microcoulomb. Okay. Now for the reaction of your positive charge of your this one, your electric field for 12 microcoulomb, therefore going repel. Okay, we have repel. Reaction of your okay, for the reaction. For E12, while for E of your 2 microcoulomb is repel again. Therefore, this one is for your this one is for E2 of microcoulomb. E2. Okay, for for the electric field of your negative 8 microcoulomb, since this one is negative charge, of course, the reaction would be attract. Okay, therefore, this one would be attract for E of your 8 microcoulomb. E of the 8 microcoulomb. Okay, E8. Okay, now we have the reaction, attract, repel, repel. Okay, first, formula, we have E is equal to KQ over R squared. That is the formula for the electric field. Now for E, E2, electric field for 2 microcoulomb, that is equal to 9 times 10 to the 9. Then your charge is 2 microcoulomb, 2 times 10 to the negative 6 over the distance of 45 centimeter. Okay, 45 times 1 meter over 100 centimeter squared. Cancel, cancel. E2 is equal to, okay, this one is equal to 89 kilonewtons. Okay, then for E8, for E8 is equal to 9 times 10 to the 9 times 8 times 10 to the negative 6 over R squared, that is 45 centimeter times 1 meter over 100 centimeter squared. Okay, what is the value? Okay, this one is equal to 356 kilonewtons. Now for E12, E12, E12. E12 is equal to 9 times 10 to the 9 times 12 times 10 to the negative 6 divided by 45 times 1 over 100 squared equal to, we have equal to 533 kilonewtons per coulomb. I forgot the coulomb. Coulomb per coulomb. Okay, therefore, P that we have get the value of your EX. Okay, now for the summation of X, that is equal to 89 minus 33. 89 minus 533. 533, that is equal to negative 444 kilonewtons per coulomb. And your Y, summation of Y, that is equal to, we have your E8, that is 356. 356 kilonewtons per coulomb. Okay, getting the figure, we have negative 44. Okay, therefore we have since negative 444 going to the left, we have 444 kilonewtons per coulomb. Then 356 kilonewtons per coulomb. Then this one is your electric field. Okay, using the Pythagorean, we can say that your E now is equal to square root of negative 444 squared plus 356 squared. Using Pythagorean formula, E now is equal to, or we have E is equal to 569.1 kilonewtons per coulomb. Okay, that would be the magnitude of the electric field. Therefore, this one is the magnitude of the electric field. While the direction, this one is your angle theta for the direction. Okay, therefore, this one is your P. Okay, therefore, let us use tangent theta is equal to 356 over 444. Theta is equal to arctan 356 over 444. Okay, theta is equal now to, okay, theta is 39 degrees. Therefore, we have to get for the P, we have 180 minus 39. 180 minus 39 is 141. Therefore, the direction P is equal to 141 degrees. 141 degrees.